Today we're going to look at the rate law of the fading dye using Beer's law. And so I have set up the lab already for us, and you'll see that I have a LabQuest with a spectrometer attached to it. I've got a beaker full of a 25 micromolar solution of crystal violet. And then in each of the test tubes are successive dilutions of that solution going from left to right. We go from 25 micromolarity down to 0 micromolarity. And so we're going to go through and run our initial Beer's law curve at 510 nanometers, which is what the lab calls for, going from the 0 micromolarity up through the 25 micromolarity. And then we'll do the second part of the lab where we'll actually look at measuring the reaction rate. Now I have placed our cuvette in the spectrometer, and the cuvette has the 0.0 micromolarity solution in it, or just straight distilled water. And I'm going to zoom in on the LabQuest, and all we'll be seeing are the numbers as they come up as we change solutions. This is a reading at 0 micromolarity, 5 micromolarity, 10 micromolarity, 15 micromolarity, 20 micromolarity, 25 micromolarity. This is our full data table from the first part of the experiment. You'll need to graph the data, put in a trend line. So you want to do a scatter plot, put in the trend line, and also find the formula for the slope of the line. And then we can use that to do calculations of our concentration at any given point in time in the second part of our experiment. I've reset up the LabQuest for the second part of the experiment, and it calls for us to mix a 6 milliliters of the 25 micromolar crystal violet with 4 milliliters of 0.2 molar sodium hydroxide, mix it, and then put it immediately into the spectrometer and take a measurement every 30 seconds of the absorbance for 5 minutes. And so everything's set up. The spectrometer the LabQuest will make the measurement itself, and the numbers will change on the meter at every 30 seconds. Now I'll mix the two solutions together, put them in the cuvette, and start the LabQuest to record our data. Zero seconds, or the initial reading. 30 seconds. After 60 seconds, 90 seconds. $120 seconds. $150 seconds. $180 seconds. $210 seconds. $240 seconds. $270 seconds. And 300 seconds. In Excel, you'll need to set up a data table similar to what I have here, where you have time and the absorbance, and this is the data from the second part of the experiment that we collected. And you need to fill in the columns for the natural log of the absorbance and 1 over the absorbance. You will then need to graph all 3 of the sets of data to see which one gives you the best straight line graph, and then that will tell you the rate law that you need to use for this experiment.